It is July 17th, 1944. The bocage country of Normandy has turned into a grinding meat grinder. A young soldier crouches in the shadow of a Norman farmhouse, his uniform caked with dust and something worse. Around him, the sounds of battle have reduced to something almost mechanical, the endless percussion of small arms fire, the irregular crump of mortars, and underneath it all, the deep, resonant growl of approaching German armour. Through a gap in the ruined stone, he can see it now. A Panzer IV, its gun turret swivelling methodically, searching. The farmhouse wall will not stop it. Nothing in this soldier's section has stopped any of them. He reaches down and picks up a weapon that looks, quite frankly, like no one bothered to finish designing it. It is angular, awkward, and utterly unlovely. All sharp corners and protruding springs, as if someone had welded together the spare parts of a dozen different machines and called it a gun. This is the PIAT, the Projector, Infantry, anti-tank. It weighs 35 pounds. It bruises shoulders. It refuses to fire in the cold. Senior officers called it a disaster. Yet this soldier, and thousands like him across Northwest Europe, had nothing else. Within seconds he would fire it. Within seconds that Panzer IV would stop burning. The PIAT would never become famous. It would never inspire monument or memoir. It would become instead the weapon that almost wasn't, the solution that almost wasn't tried, and in the desperate mathematics of modern war, the difference between soldiers who came home and soldiers who did not. The British Army in 1940 faced a problem that seemed to have no answer. The German invasion threat had receded only slightly when a new, more insidious threat emerged: the increasing sophistication of enemy armored vehicles. By 1941, the standard anti-tank defense available to infantry battalions was the 2-pounder gun, a towed weapon that required a crew, consumed ammunition at an alarming rate, and worst of all, could not be carried by infantry sections operating independently. When those sections encountered tanks away from prepared positions, they had almost nothing to offer in response except prayer and hand grenades. The defeats in North Africa made this inadequacy catastrophically clear. British forces, often outnumbered and always desperate, found themselves repeatedly unable to stop enemy armor. German tanks, operating in the open desert where they could not be hidden or entrenched, hunted British infantry with near impunity. The casualty lists told the story. Over 10,000 men lost in one sector in merely 3 months. Those numbers haunted planners in Whitehall. The mathematics of modern warfare had fundamentally changed. Tanks were becoming faster, better armored, and more numerous. The old towed anti-tank guns designed for static defense could not answer this challenge. What the British Army needed was something revolutionary. A portable anti-tank weapon that an infantryman could carry, could operate without a crew, and, crucially, could be produced in vast quantities. It needed to be light enough for a soldier to transport but powerful enough to penetrate tank armor. It needed to be simple enough that a 17-year-old from Liverpool or Devon could fire it after 30 minutes of instruction. Existing solutions simply did not exist. The Americans had experimented with shaped charge ammunition, but had abandoned the concept as too dangerous. The Germans had no portable anti-tank weapon at all, relying instead on their tanks' superiority. Britain stood alone with a problem that seemed unsolvable. Enter the War Office Experimental Station, buried in the rolling countryside of Tuxford in Nottinghamshire, where a group of engineers and ordnance designers had been given an impossible mandate: invent the future in 3 months. Leading this team was Lieutenant Colonel Stuart Blacker, a brilliant, temperamental officer with a reputation for thinking laterally when conventional solutions failed. Blacker understood something that many of his contemporaries did not. The shaped charge principle, developed by researchers in Switzerland and Austria, offered a path forward. A shaped charge, when detonated, focuses the force of the explosion in a single direction through a specially formed copper or steel liner, creating a jet of superheated metal that moves at extraordinary velocity, nearly 25,000 feet per second, exceeding even the speed of a rifle bullet. This jet could punch through armor plating that would shrug off conventional bullets, yet the weapon itself could be relatively light. The concept was revolutionary, but realizing it in a practical weapon that infantrymen could actually use proved fiendishly complex. Blacker's team settled on a spring-loaded launcher design. The weapon would be built around a massive coil spring, pre-compressed by the soldier's weight pressing down on a pad beneath the barrel. When the soldier pulled the trigger, the spring would release with violent force, propelling a hollow-charge projectile toward the target. The projectile itself was small, only 6 inches long, but its warhead contained a charge that could defeat nearly 4 inches of homogeneous armor plate, far thicker than anything encountered on contemporary tanks. The entire assembly was manufactured from pressed steel and light alloys, keeping the weight manageable. Production was contracted to companies across the Midlands. The Spring Motor Manufacturing Company produced key components, Marmon Harrington handled the main body assembly, and final assembly occurred at several locations including the famous Small Heath Works in Birmingham. By late 1943, production had reached approximately 200 weapons per month, a figure that would eventually rise to nearly 400 monthly as the manufacturing process was streamlined and refined. Estimates suggest that by the war's end, over 100,000 PIATs had been manufactured, though records remain incomplete as many production records were dispersed or destroyed during the bombing campaigns. When the PIAT finally entered service in North Africa, the response from soldiers was mixed at best. The weapon was undeniably effective against tanks, this was immediately apparent. But it had grievous disadvantages that no amount of bravery could overcome. The enormous recoil, generated by the violent spring release, bruised soldiers' shoulders and occasionally caused fractures. In cold weather, the spring became so stiff that it barely functioned at all. The projectile's velocity was relatively low, meaning soldiers had to be absurdly close to tanks to have any reasonable chance of penetrating the armor. Anything less than 100 yards was considered ideal range. Attempts to fire at 500 yards or beyond were largely futile. There were also disturbing incidents where the weapon simply misfired, the spring refusing to release despite the soldier triggering the mechanism. During the Sicily campaign in 1943, frustrated infantry officers described the PIAT as a death trap, and worse. Yet ironically, it was precisely this inadequacy that eventually led to its vindication. Soldiers, faced with no alternative, learned to use the weapon as it demanded to be used. They learned to close to short range. They learned to aim for vulnerable points on tanks, the thinner side armor, the engine decking, the turret ring. They learned that a PIAT round, while it might not penetrate a Panzer IV's frontal plate, could absolutely gut a tank if the shot landed properly. Accounts from Normandy describe desperate men crawling toward stationary German tanks in the bocage, waiting for the turret to swing away, then firing from 20 or 30 yards distance. In July 1944 alone, PIAT teams were credited with disabling or destroying over 200 German armored vehicles in the British sector. These figures admittedly are estimates. The fog of war makes precise accounting impossible, but they are supported by German records of tank losses and subsequent after-action reports. If you are finding this fascinating, a quick subscribe to the channel helps more than you know and ensures you'll catch the next episode when it arrives. The question of why the PIAT succeeded where other anti-tank weapons struggled requires a comparative examination. The German Panzer IV, introduced in 1943, was in many respects superior. It was lighter, less prone to mechanical failure, and its shaped-charge warhead was more powerful. Yet the Panzer was produced in vastly smaller numbers than the PIAT. Manufacturing the Panzerfaust required significant resources and precision engineering at a time when German industry was fragmenting under bombing and resource constraints. By 1945, only 3 million Panzerfausts had been manufactured across all variants. In the same period, the British and Commonwealth nations had distributed something approaching 2.5 million anti-tank weapons of various types, with the PIAT being the most numerous. The American bazooka, introduced slightly later than the PIAT, offered similar performance characteristics but suffered from similar limitations: inadequate penetration against frontal armor and the requirement to close to very short range. The real difference lay in scale and persistence. The British, having committed to the PIAT, manufactured it relentlessly and distributed it to every infantry battalion and airborne unit. Soldiers who might have been armed with the 2-pounder gun, cumbersome, crew-dependent, and essentially immobile, were instead equipped with portable weapons that gave section commanders real anti-tank capability. Moreover, the PIAT became the template for post-war designs. The Soviet RPG principle, which dominated anti-tank doctrine for decades, owed a clear debt to the shaped charge revolution that the PIAT had pioneered in service. The Swedish AT-4, the French LRAC, even elements of modern American anti-tank design, all trace lineage back to the fundamental concept that Blacker and his team had validated. The strategic impact of the PIAT, however, remains genuinely contested. Did it fundamentally alter the course of the war? Almost certainly not. Tank-on-tank combat decided most engagements. Artillery remained the primary killer of tanks throughout the Second World War. Yet the psychological impact on both sides was profound and measurable. German tankers, by 1944 and 1945, had learned to fear infantry. They developed tactics designed to avoid close-range engagement, staying at distance and using their superior firepower. This, in turn, limited their tactical flexibility. A panzer that cannot confidently press an attack against defending infantry is a panzer operating at reduced effectiveness. More importantly, the existence of the PIAT meant that small unit commanders, sergeants, and second lieutenants possessed real agency in anti-tank warfare. They were no longer entirely dependent on higher-order decisions about gun placement and deployment. This fundamental shift in the distribution of anti-tank capability echoed through decades of subsequent military doctrine. The idea that every infantryman, or at least every infantry squad, should possess some capacity to engage armor became canonical in NATO planning. The PIAT did not win the war, but it helped win the condition that allowed the war to be won. Today, perhaps 15 or 20 original examples of the PIAT remain in museum collections worldwide. The Imperial War Museum in London possesses 3 examples, one in pristine condition, and 2 showing the kind of wear that speaks to hard wartime use. The Royal Armouries in Leeds holds another. Several intact weapons rest in the National Collection in Aberdeen. To see a PIAT is to understand immediately why soldiers found it so disagreeable. It is angular, awkward, aggressively ugly. The massive spring apparatus dominates the weapon visually. The recoil pad is enormous, speaking directly to the violence lurking in that compressed spring. The sights are crude by any standard, yet to see it is also to understand why it mattered. This is not a weapon designed to be elegant. It is designed to be produced. Every line, every angle, every component speaks to manufacturing efficiency. The PIAT could be made by semi-skilled workers. It could be produced with the machine tools available in 1943. It could be transported, maintained, and repaired under conditions of extreme duress. It represents, in its ungainly form, a profound truth about modern warfare. The side that can solve the manufacturing problem, not necessarily the design problem, possesses tremendous advantage. We began with a soldier in Normandy, desperate, holding an ugly gun. What was true in that moment became true across the entire northwestern European campaign and beyond. The PIAT was never perfect. It was frequently maddening. In surveys of British soldiers conducted in 1945, when asked to rate their weapons, The PIAT consistently ranked lower than the rifle, the Sten gun, and even the hand grenade. Yet, when those same soldiers were asked which weapons had saved their lives, which weapons had turned moments of desperate vulnerability into moments of tactical possibility, the PIAT appeared with startling frequency. It was a gun so profoundly ungainly that senior planners nearly shelved the entire project. It was a gun that bruised, that failed in cold weather, that required suicidal bravery to employ effectively. It was also a gun that, through sheer bloody presence, through being distributed in vast quantities to men who had no other option, through simple persistence, changed what warfare at the small unit level could be. That Panzer IV in the Norman farmhouse burned because a 17-year-old kid from the East End chose to inch forward across open ground, knowing that the only weapon he possessed was barely reliable, barely effective, barely anything at all. Yet, he went forward, and in going forward, in refusing to accept that desperation was destiny, he found in that ugly metal shape something that worked. In the terrible calculus of war, sometimes that is enough. Sometimes the ugliest solutions prove to be the truest.